And I'm live. Yes, I'm live. Today is 21st of July 2025. And is there anything else that I can say? Except from the fact that I want to become a good programmer. And if I become a good programmer, I will be able to earn money. And if I can earn money, I will have power. And if I have power, I will have freedom. And if I have freedom, I can watch anime. So let's begin. I can stop myself there. And yep, okay, here. Where am I right now? I am in the right folder. Yep, yep, 1100. That is cool. And CP31, 1100 subsequence edition hard. Shit. Let's see. Subsequence G2 edition hard. So maybe I have already done the easier version for this thing. Where do I see the problems? Wait, these are problem set. Okay, yes, this is good. This is good. G2 subsequence edition hard 1818. Is that how you look for questions? I don't know. Let's just begin with the question. The only difference between the two versions is that in this version the constraints are higher. Okay. Initially, array A contains just the number 1. You can perform several operations in order to change the array. In one operation, you can select subsequence of A and add A and add into A an element equal to the sum of elements of the subsequence. Okay, you are given a final array C. Check if C can be obtained from the initial array A by performing some number, possibly 0, of operations on the initial array. Okay, I am given an array. Okay, and where is the array C? Um, First line contains n, and the second line of each test case contains n spaced integers ci. Okay, initially it is the same in all the cases. Okay, so in this case it is true. In this case it is not true. Nope, it is false. Yep, and in this case 1. No, I can only have 1. Why is it yes in the third case? Okay, if I choose 1 again, okay, makes sense. So what I can do is put in any number of ones. That is true. Okay, 5. If I do 1 and the number performing some number of operations, possibly 0, you are given a final array C. You can perform several operations in order to change the array. In one operation, you can select some subsequence and add into A an element equal to the sum. Okay, and I can add that element anywhere I want, I suppose. And if that is the case, then I need to know that given every element here, does there exist a subsequence which can give that sum? For 5, there exists 3 and 2. For 1, there is 1. For 3, there is 2 plus 1. For 2, there could have been 1 and 1. Okay, which means these two elements came afterwards. Okay, for 7, I have 5 and 2. So I can simply sort this and see if they match. Yeah, for 1, there is 1. For 5, there is no sum that I can do. Yeah, so that is wrong. That is wrong. 5. So no for this, and it is no. For 1, yeah, it is true. I can do that. For 4, I have 2 plus 1 plus 1. Mm, so that is what I have to do. Okay, for every element, I just have to find is there a subsequence which adds up, but the subsequence can appear in any order. And okay, if I sort it, then I can traverse from the right and find a subsequence on the left of that element. And I will always have 1 in the array. So after sorting this, if I start from 7, I go down to 5, and then I will see 2. But how do I find a subsequence that using 2 pointer method? I guess for that I would need a way to add element subsequence, and I am supposing that 5 plus 2, what if 2 was not here? What if it was 5 plus 1 plus 1? And what is the maximum size of n? Maybe I can create a n square grid. N square grid. Can I create a n square grid? But that would only include 2 elements. Okay, it is not that hard. The only thing that I have to solve is how do I find if there is a subsequence for every element in this array which has sum equal to this thing. And I have an assumption that when I sort this thing in ascending order and traverse from the last, that is the greatest element, then the subsequence that adds up to form that big number will be continuous. That is, the elements that are adding up to form the bigger number appear side by side, because and they will all be to the left because the array is sorted now, and since it is sorted, only smaller numbers will add up to make a bigger number. And I will keep going left, left, left. I can use 2 pointer array method, and if I see, I don't think that would work. I don't think that would work. Let's say, in which case would it not work? I have a sequence and I have made it something like I can choose a subsequence. Hmm. Would order mean anything? I don't think the order would mean anything because the number that I make, I can put it anywhere, but it has to be put into place at some place that would add up with the previous numbers to make 6. What if 6 was here? Like, what if I had 6 here? Then, what if I had 7 here? 6, 7, it would be cool. Like, I can add 7 right now. 3, 2, I can also have 2, I can also have 5, I can have 3, 1, 2, 3, 4, I can have a 4, 5, I can have a 5, 6, 7, 8, 9, line. if I have numbers sorted, say I will always have 1 in the start, then let's say I want to find a subsequence that adds up to make 7, and I have 1 at the start, and possible numbers, possible subsequences. Shit, maybe it could take a lot of time. What is the time complexity? 2 seconds. And log n I have already used, and log n to sort the array, and log n. And then a possible subsequence would be 3 plus 4. But let's say I have 5. 5 needs 2, and here 4, and then 2. Yep, in this case I will not be able to find a subsequence which adds up to 7. But is this like even possible? Let's say I initially I had 1, then I chose this subarray, and then I had 1 1, and then I chose this subarray, and then I will have 1 1 2. Okay. But I think in this case it will not be possible. 4, to make 4 I would have to choose all of these and all of, yes, if I choose all of these, I can add 4 here, 1 1 2, and then to make 5 I can choose this subarray. So 4 1 1 2 5, and then to choose to make 7 I can just choose these two elements. I will have 7, so order does matter. 1 1 2 5 and 7. This is what I have at the end. Okay, and if this is the case, yes, you guys can see. If this is the case, then sorting would mess things up. And yeah, sorting, I would not be able to find the subsequence that adds up. Maybe I can use some recursive function. Let's say when I start traversing from 7, I go to 5, and then I see the difference, that is 2. So I say that I need 2. Then I look for a subsequence in the remaining array that gives the sum 2. And I look at 4, I say that it is too big. I go to the left and I see 2. And when I see 2, I say, yes, we are done and let's go. When I go to 5, I look at 4 and I say I need a subsequence from the remaining array, which is this much, which is this much, and I need a sum of 1 from this. Then I look at 2 and I see that it is too big, so I move left and I find 1, and then I need 0, some 0 more value to make 4 up to 5. So we are cool, I found that. Then look at 2, and I need a subsequence from these two numbers that adds up to 2, and I look at 1 and I say I need 1 as a sum from the remaining array, which is this much, and it only contains 1, so that is cool. And then I go to 1 and I look at the remaining array, which is 1, and to make 1 from 1 I need 0, so we are also cool in that case. but how much time it would take. Could take a lot of time. And log n to initially, let me remove a few things. So time complexity could become a hassle. It took and log n time initially to sort the array. And then I'm looking for subsequences that add up to make a number. But but this could also not. Wait, if this is true, then I am guaranteed, if this thing does work, then I'm guaranteed to have a subsequence in this array that adds up to 7. Right, then I'm guaranteed to work that this would work. And if that is guaranteed, if okay, okay. I think I can sum this whole thing. Mm. Then I'm guaranteed to have a few elements in here that add up to 7. Okay, and let's say I sum this whole thing, this whole remaining array that is becoming too big. Wait, this is my array 1, 1, 2, 4, 5, 7. No, this is not 7, this is looks like 1, 7. And I need to find a subsequence in this array that adds up to 7. And if I suppose that this is true, that there is a subsequence which actually is this and this that adds up to 7, then I don't even need to find the elements that add up to 7. I just need to know that they do exist. So let's say I can have the sum of this thing. That would be 2, 4, say, 8, 13, and I subtract 7. I get 6. 6 is the sum of this and this. Does that help me? Nope. And if this is like actually true, then I'm also guaranteed to have a subsequence whose sum is 5. Wait, if there is a subsequence whose sum is 5, which in this case is 4, 1 and 4, I think I can do something crazier. The total sum is 1 plus 1 plus 2 plus 4 plus 5 plus 7. Hmm. That would be the total sum, which is 20. And this 2 does not look beautiful, which is 20. And let's say 7 is the biggest number. So I know for a fact that 7 has only been added once. 7 being the biggest number has not been added multiple times because it has not been a part of a subsequence and it is the biggest number. So if I remove 7, then I will get the sum of this subsequence, which is like fucking normal, does not mean anything. But then if I look at this subsequence and go with the same logic, I can say 5 has not been added. No, 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 no. I would just continue on removing these letters, and at the end I will have 0. Does not, that doesn't help. 7. If I remove 7, and if I remove 7 even from this smaller subarray, then I am guaranteed to remove a few elements. Okay. Uh, the point I'm trying to get at is I started with 1, then I chose 1 as my subsequence. So how many times have I added this 1? I found this one. Let's count for every element how many times I have added that number. This one, it was included in the first subsequence, so 1. Then I had another one, and I'm chose this subsequence to make a 2. So to make a 2, and so this one was used twice at that point, and this one was used only once. Then I chose this subsequence to make a 4. So this one was used 3 times, this was used 2 times, and the 4 and 2, 4 is used 0 times and 2 is used 1 times. Then I chose this subsequence to make a 5. No, then I chose 4 and 1 to make a 5, and that one can be any one. Let's say this one. No, it cannot be anyone, it has to be the first one. So 4, 2 and 1, and then I chose 5 and 2 and 5 to make 7, 2 and 5 to make a 7. So 2 was used twice and 5 was used 1 time. So if I do 4 into 1, I get 4 plus 1, 2 plus 4 plus 4 plus 5 plus 7 into 0, 4 plus 2, 6, 10, 14, 19, 19. Does 19 mean anything? 19. 19 does not mean anything. Oh, 19 does not mean anything. Shit. Mm. And I'm solving this question, by the way. G2 subsequence hard. Problem number 1807 G2. When starting from the biggest element, if I start from here and if I start from, wait, let me write it again. 1, 1, 2, 4, 5, 7. This is not my actual sequence. The actual sequence was 4, 1, 1, 2, 5, 7. And if do I have to sort it? If I take the smallest and I subtract that from every element, nah, 7, I'm guaranteed to have two numbers that, okay, when I take when I take the biggest number, then I know that the numbers that make that number up are appearing side to side, because they have to appear because no number was added. So okay. I can create a copy of this array and I can sort that. Then I can start iterating from the biggest number, and then I find that the biggest number is 7. I take that number away from the original array. So my original array becomes this much, and then I have to look for a subsequence that adds up to make 7 as the sum. But how do I do that in an unsorted array? Because I don't even know the length of the subsequence. How would I find a subsequence? Because if I were able to find the subsequence, I can remove this and confirm that there is a subsequence that exists and remove this. Then I can go to the second largest number, remove that from the array, and this much would be my array, and then find another subsequence which adds up to make this number. And after confirming that, I can go to the next largest number and then see a subsequence, see if it adds up to make this number, and when that is confirmed, go to the next largest element and find a subsequence in the remaining array which does exist, and then go to the next and go to the next and keep confirming. But how do I find a subsequence that adds up to something and the subsequence is not sorted and the order does matter? Order does matter, and I can add numbers anywhere I want. Right. If I go from 7, 5, for 5 I need a 2, which I do have. If I go to 4, I need a 3 to make 7, which I do have. If I go to 2, I need a 4 to make 7, which I need a 5 to make 7, which I do have. For 1, I need a 6, which I can make. And for 1, I need a 6, which I can make. Does that mean anything? Wait, fuck, yes. The actual answer would be 5 and 2. But 5 and 2 themselves came to order because of other numbers. That is, 2 came because I added these two, and 5 came because I added 4 and 1. So 4, 1, 1, 2, 5, 7. Here I have to add 2 and 5 to get 7, and 2, I got 2 after adding 1 and 2, 1 and 1, and I got 5 after adding 4 and 1. I got 5. So. Yeah. Oh, the length of the subsequence could be anything. What if I like choose this as my subsequence and then add a number? I will have 13 here. What would I do then? C7. I would like to find if something adds up to 7 to make 13. Yes, that would be 6. 6 plus 7 equals 13. And do I have the ability to make a 6? I do have the ability to make a 6, which is like right here. Let's see. I mean concept art. I guess practice. You have to practice. If you know the concepts and you are unable to find patterns, then practice, solve questions like these. Or you can do advent of code, which is pretty fucking amazing. Advent of code. Here you have a lot of questions. Go to any day. There is a question, solve it, and you will find a dialog box here at the bottom, input box, and you can enter your answer at the bottom, which is pretty cool. But here it has been 30 minutes and I've been unable to solve this one question. I feel like I'm getting closer to how to solve this, but for every big number there exists a subsequence which adds up to make that a big number. I can go up to n square. And there are no negative numbers. That is also cool. Make the bigger number 0. The only problem is how to find a subsequence in a array that adds up to a target. That subse a subsequence in an array that can be derived from another array. A subsequence is changing the order. Closest subsequence sum to target. This is something similar. Shit, this much. Given an integer array A and an integer target, the task is to find a subsequence or array such that the absolute difference between the absolute difference between the sum of the elements and the target is minimized. Return the minimum possible value of that. Okay, I need to find 0. Subsequence of an array is an array formed by the approach. can I look at it? I have given this question 30 minutes. So let me think about it for a while and then I will look at how to find this subsequence which adds up to find to a target. Okay, I take the whole sum, and then I look at this number. And if that number is smaller than my target, then I keep it. If it is larger, then I can simply remove that number, right? Let's say I'm looking for a sum 13 and I see this. Then I look at the borders. I find 4 and 7. Then I can, which one do I remove? Think I can remove the bigger one. Well, in this case, if I do remove the bigger one, the sum of this whole thing would be 20. And I see 7 and 4. If I subtract 4 from 20, I get 16. And if I subtract 7, I get 13, which is exactly correct. So I remove 7 and I see this and I have found my subsequence, so I can move on. Then I look for 7 for a subsequence that adds up to make 7. And after that I can just make 13 equal to 0 because then I can add 13 in a subsequence, but it would not contribute anything to the sum since it is 0. Then I need to find a subsequence that adds to 7. I can initially make 7 equal to 0 and then I can look at the borders. And the whole sum is now the sum of these elements, which is 6 plus 2, so 8, 8 plus 13. Whole sum is 13. Then I look at 0 and 0, and removing 0 would not change the sum, so I can remove both these zeros. When I am here, I see 4 or 5. If I remove 4, then the sum would become 9, and if I remove 5, then the sum would become 8, and 8 is closer to 7. So let's say that I do remove 5, then I will be left with this thing, and with this thing, then no matter which number I remove, the sum will be lower than 7, which is wrong. So I remove 4 and then this is my subsequence, and then if I remove 1, I could remove 5. I cannot remove 5 anymore because the sum would be lower than 7. So I remove 1 and then again I remove 1 and then the sum of this subsequence is 7. That doesn't help me. It would be much better if this smaller array was sorted, but I cannot do that because the order here does matter. Yep, the order does matter, right? Yep, yep, the order does matter. So let's look at this. Currently, I'm following Striver's sheet, the same thing that I'm following. Shall I start doing code forces div 2 or 3, but I fear to lose my rating. That's why I am not starting code forces, because earlier I lost ratings in lead code. Well, to that I would say, don't be afraid. Simply that. Don't be afraid. Don't be afraid. Yes, just that. Don't be afraid. This is what Ragnar Lothbrok said. Let's see. Don't be afraid. Uh, don't be afraid to. I've said this thing.
I have some good news. King Egbert
Oh shit! Wait, I cannot hear. Wait a minute.
has arranged for a boat. You are going home. I'm not going without you. They aren't going to release me. I have to die. This Hela is going to kill you, then me and all my brothers will seek her for revenge, and you know that. Yes. Oh, you must seek revenge. But not on Hela.
Shit.
On Egbert.
I think right here.
I might have been happy. Happiness is nothing. I was only joking. Idiot. Unpredictable. Many gifts. Anger is a gift. What is in here is a gift. You do not think like other men.
Shit, he does not say this to Ivor. He says this to the King Egbert. I'm looking for that very specific scene. I think this is the one.
I cannot kill you. Yet you must die. This much is certain. In return,
I will tell my son Ivor to tell his brothers that you did everything you could to save me. That you and I, we are sworn friends. And
This.
don't be afraid.
Right. Don't be afraid. And now this approach. To solve this problem, we need to find a way to explore all possible subsequences efficiently. Yes. One effective approach is to use the meet in the middle technique. Yes. We split the array into two halves and consider. You should have heard about we split the array into two halves and consider all possible sums for each half. All possible sums for each half. By doing so, we reduce the problem size and can find the closest sum to the target efficiently by binary search. Yes, it isn't something like this. If I have this subarray 2, 3, 4, or like anything, the one that was above 2, wait, 4, 1, 1, 2, 5, 7, and I'm looking for the sum 13. Then I split the array in half from here, and my target array could have a few possibilities. Either the sum the target array is totally in this half, or it is totally in this half, or some part of this half plus some part of this half, something like that. And boom. Nah. Okay, let me read it. Don't remember. Split the array into two halves. Calculate all possible sums of subsequent subsequences of each half. Sort the list of sums from the second half for each sum in the first half. Use binary search on the sorted sums of the second half to find the closest possible sum to the target. Keep track of minimum absolute difference between total targets. Return the minimum absolute difference found. Generate all possible subsequence. This will take too much time, like n square time for finding one sum. So this is not cool. Number of subsequences that satisfy this lead code with sum equals k. Yes, given an array length n, all subsequences, sum equal to k. Approach. The idea is to generate all possible subsequences of the given array and store the subsequent subsequences with sum of its elements equal to k. Nah, does it still take a lot of time? And k find subsequence. Find subsequence takes index sum k vector and another vector and then a vector like this. This is what are all the subsequences? One is this, one is this, one is this, one is this, and this, and then this. Then I start from here. This is one subsequence, one subsequence, one subsequence. There are in total n square subsequences. Let me look at the editorial. It has been long enough. Thanks, bro. I'm going to start CP from next week. Should I start off with Div 2 or 3? You can start with any division, does not matter. We have a Code Forces contest on 22nd, like day after tomorrow. No, tomorrow is 22nd, today is 21. This contest 818 for Div 2. You can participate, that would be cool. You can participate in this one. And for earlier Div 2 contests, you can see people. I think it is good for you to participate in these questions, in these contests, because even if you are able to solve a small number of problems, like even if you solve one problem, your rating would be improved. Like standings, if you go to the end, how do I sort this in the opposite order? I don't have to. Okay, this guy was the last. He was only able to solve one question. Why is it minus 17? It took him 1 hour to solve one question. That is crazy. And he is at specialist. Okay, he lost a lot of rating. Yes, now I can read the editorial of this one. G2. Subsequence. Shit. Russian. Russian or Russian, probably Cyrillic. Let's prove that for an array A that was created by using a number of operations with a sum of elements S, we can add n into A any number x such that x is less than 1 and s is the sum of the total array, sum of all the elements. Suppose that it is true that in the array A, okay, I can add any number x, can I? Because I have 1, I can always add 1 a number of times. Okay, I think, yeah, in one operation. Suppose that it is true that in the array A with some length L, we introduce a number x such that x is between A and sum of A, which is s. Then after introducing, we can create, using the initial elements of the array, any number b which is between A and the new sum, and using the element x and some subset of the initial elements, we can create any number b which is between at least x, because we are including a x, and the sum plus x. Okay, yeah, the upper range has increased. We proved, and because x is lower than equal to sum a, we proved that for the new array of length l plus 1, which has x also, that is why l plus 1, we can still create any number between 1 and x plus 1. Okay, this was the initial presumption that we added this. Okay, they are using induction of some sort to prove this. We proved that for the new array of length l plus 1, we can still create any number between this and this. How? Because you can do this thing. Okay, they want to prove this thing, right? Let's prove that for an array this is true. Suppose that it is true that in array A with some length L, we introduce a number x, right? This is, yeah, okay, this is totally valid. We can introduce a number x, but we are not saying that we can introduce every number that is between sum of A. Then after introducing x, we can create, using the initial elements of the array, initial elements of the array, initial elements of the array, any number b which is between any number b, using the element x and subset. We can also create this, any number b, and using the subset and some elements of the initial array. K elements and subsequent of the array elements, we can create any number b, and because x is lower than sum, we proved that new array of this length can still create any number between 1 and sum of x. I do not get this part. Since it is true for the initial array, we can use induction, and this fact to prove it is true for all arrays. So we need to verify if our array satisfies this condition. We should sort the array and check for each this I between 2 and n, the second element and the last element. If Ci is less than this thing, which is the sum from the first till the element that we are at. Less than the sum. I do not understand this part. And the solution is not that long. Best resources to learn DSA or any roadmap, please. That would be this thing. Don't look for the best, just find anything and start working with that. You can go with this Striver's sheet, take you forward, TUF. I am also doing this thing, and currently I'm here at sorting and stuff. So yeah, you can do this. That is cool. Let's prove that for any array A that was created by using a number of operations with the sum of elements S is the total sum of elements. We can add into A any number between X and okay. If I have an array whose sum is this, is it true? Is it true? Is it true? Tell me now. 4, 1, 1, 2, 5, 7. Here the sum is 20, and they are saying I can add any number between 1 and the total sum, let's say 19. How do I make 19? I make 19 by adding. I have to remove one of these ones, but subsequence I cannot make 19 directly. Nope, I cannot make 19 directly. Nope. For 19 to be possible, this 4 would have been here, and only then I could have made 19. Like this, by choosing these numbers. But right now I cannot make 19 directly. So isn't that false? Let's prove that for any array A that was created by using a number of operations with a sum of elements S, we can add into A any number. I can add 1, I can add 2, I can make, if 4 was here, I wouldn't be able to make 3 because I would need a 1 beside a 2. And if 4 is in the middle, I won't be able to make a 3. And I can make a 4 simply because I have a 4. 5, I can make a 5. 6, I can make a 6. 7 right here. 8, 2 plus 4 plus 1 1 something. 8 would also be possible. 9 would also be possible. But I cannot create a 19. Because the order depends. Yep. So I cannot sort this thing. So we verify, we should sort the array and check for every element this. Okay, I am going to use ChatGPT to understand this thing. And I think I know I have given enough time and thought to this. And they're like something tags, uh, not this. No, no. There was a competitive companion, Code Forces helper. show submission rating, context, participation checker, save questions, multi-user rating, exit font, greedy, DP, implementation, sorting, bit masks. Okay, I don't know bit masks. I've heard a bit about this bit masks, but I don't know exactly. DP, I have solved a few easy questions on DP. Greedy, I know the conceptually, but I have not practiced enough. Implementation, of course, you have to implement. In sorting, I know sorting. And 1100 level, this thing. And you can use ChatGPT from time to time to understand, because I have the solution. I can just copy paste. I don't want to do that. I want to understand what this thing means. All right, and then type the solution on my own. To start with this, okay, I start with this. You follow the allowed operation is pick a subsequence of A, compute the sum of all the elements in that subsequence, append that sum. Fuck. In one operation, you can select some subsequence of A and add into A an element equal to the sum. And by add, fucking add, shit. They mean I can only add it at the end of the array, but no, I cannot. Yes, fuck, I do. This one. I got this one because there was a one here, and then I got this two when I chose these two. Then how the fuck did I got this four? The only way that I could have gotten this four would be to have this two paired up with these ones, and so yeah, I do not always append the element to the end. So this thing is wrong. This is wrong. I don't always have to append the new element at the end. I can add the new element wherever I want. Excellent. Let's reset and analyze carefully. This time you are absolutely right. The problem now says you must append at the end. You can select some subsequence and add it to A. So placement in A doesn't matter at all. The array isn't ordered in any meaningful way. All that matters is what actually happens. Each time we pick a subsequence and add it some, we grow the multiset of numbers in A. By repeating, we accumulate more and more numbers. What is the uh, eventual set of numbers we can get? Starting with 1, at each step, take any subset of existing numbers, sum them, and add the result back. Repeat forever. And also, I have to take care of the fact that it will be taken care of. It will be taken, yeah, it will be taken care of. Don't worry. Start with 1 at each step and subsequence. Key insight: we are generating numbers using repeat subset sums of existing numbers. Okay, this means we can get any number if it is the sum of some subset of existing numbers. Okay, but new numbers themselves contribute to the future set sums. Okay, Reformulated question: given a multiset C, is there a way to form 1 and build up all numbers in C one by one by repeatedly adding subset sums? Important properties. Order would depend. Like, yeah, it would depend on the order. If I do 1, 1, 2, 4, 5, 7 here, if this is my subset, then I won't be able to make 7. I won't be able to make 5, even though I can add 2 and 5 to make 7, and I can add 4 and 1 to make this. So the order does matter, since in the array 1 2 1 1 2 4 5 7, I do have a set of elements that make up every number, but they don't appear in the correct order to be able to become a subset and make that number appear. Now we are relating the core of the problem. Now you are absolutely correct again. ChatGPT isn't helping. The subtlety: earlier we assumed since they were like multiset, but the problem says you select a subsequence of A, and subsequence means you have to select elements preserving their relative order. So the placement of numbers in A affects future operations. Because we are building a subsequence, you can only pick elements left to right. Why this might fail, even though all the numbers need there are, yes, to form 4, you could have selected this, but what if 2 appears after 4? You couldn't have used it to make 4. Yep. No, I could have, because 4 wouldn't be there before making 4. So while all pieces exist, their relative positions make it impossible. What does this mean? Start with this. For each I starting from I, check if there exists a subsequence. I can simulate the whole thing. First of all, I can sort this, and starting from the second element, first I check 1, and I can just skip it. Check it first number has to be 1, and then I go and I see the next number. Is there a subsequence in the left array which makes this possible? If is, then cool. Then I go to 2, and is there a subsequence here which makes this possible? If it does, then cool. For 2, yes, cool. For 4, yes, cool. For 5, 4 plus 1. How do I find 4 plus 1? I don't find 4 plus 1. I know pretty much JavaScript. Can I do DSA in this language? Yeah, you can do DSA in JavaScript, even though JavaScript is pretty slow. But the fact is that you are not trying to make your code faster and faster. You are just trying to learn DSA. So yeah, you can do that in any language because your goal is to understand DSA. Why is this enough? This is bad. Let me just read the code and try to understand from that what it means. I've given too much time on this thing. Solve cint take an n, okay, create the array, sort it right away. First one always 0. If it is not, then no, and return. Otherwise, long sum. Find the sum. Starting from the first element, go. And sum has to be smaller than AI. If no, if sum is smaller than the current element. Okay. Shit, if this is what we are checking. Okay, let me try to break this 1 1. And then I have 7 and I need 7. 6. Yes. 1 1 2 6 7. This array of numbers, this will pass this test, but it will starting from the first element, like second element, because 0 indexed. See if sum is smaller. If sum is at any point smaller, then output no. Otherwise, 6 would not be able to pass it. Shit, this is fucking crazy. 6 would not be able to pass it. So 3 is the maximum that I can choose. And if I do 3, then 5 plus 2, it will become 7. Shit, how is this working? Voodoo magic. Let's do that for any. That was created by using a number of operations. Into any number. With some s, you can add any element in this. Okay, then suppose that it is true that in the array A with some length L. Now this is what we are trying to prove. Okay, and this is what we are trying to prove, and this is the proof. Suppose that it is true that in the array A with some length L we introduce a number x. This is not making sense. Let's see if, where are they talking about? G. Can I? Why is everyone talking about F? For F, D, E. So no one is talking about G. This was division 4. Uh, Suppose that it is true in the array A with some length L, we introduce a number x. X can be any number. Then after introducing, we can create, using the initial elements of the array, any number b, which is here and here, and using the elements x and some subset of the initial elements, we can create any number. Using the initial elements of this array, number b can be created. and after x we have extended the range from initially x to x plus 1 to sum plus x, and because x is lower than or equal to sum, we proved that for the new length we can still create a new element between this and this. Okay, I do not understand the proof, that is the thing. I don't get the proof. Shit. This is the solution for the above problem, but I don't get the proof for this thing. Perfect, you have touched on the key lemma that makes it this problem. Click for menu. Let's break it down. What is the claim? You start with an array A created by some number of operations. AC is too hard. You create any element x which is between 1 and x by selecting this. This is the claim. After adding x to a, you can now create any number b between this and this. Okay. Why is this even important? This proves that if the array was built properly, it behaves like a progressive sum of set of sums. After each step, the range of the possible sum grows continuously without any holes. Yes, that is the word, without any holes. So ordering of C doesn't matter, and we only need to check first is this and that C is non-descending. If yes, we can always perform operations to make it. So let's discuss proof step by step. First has to be 0 after sorting the thing. Inductive step. After L operations, array A of length L has some S. We can create any number Y. How can we create any number Y here? We add a new element X. Okay. First is this claim. How can we create any number between 1 and the total sum in the array 1, 1, 2, 4, 5, 7. The sum is 20, but I can't create 19. Now you are asking the right question, so please unpack carefully on it. And you are correct. If you take a subsequence, you can't form 19. Why? Because the array may not be valid. Okay, let me give you a valid array. 4, 4, 1, 1, 2, 5, 7. This one is valid, but still I can create 19. Right? I cannot create 19. Yep, I cannot create 19. Perfect. Now we are going cooking. Okay, let's tear this apart step by step. And actually, I could have created 19 in this one just by selecting this subarray. And he said, "You are right." Yours, she, ChatGPT, anything does not matter. The array this stable, is it valid? result of the allowed operations starting from 1. Each new element must be a sub. Okay, and your array starts with 4. Hmm. The group at each step E can perform all numbers. I want to this. Testing on claim 19. We can form we cannot form 19 because this is the subarray. Okay, chat GPT is being stupid. Let's talk to Claude. Claude is better at programming, unlike me. Shit. This thing is very embarrassing, by the way. I don't think so. It is that bad. Going to ChatGPT and asking for an explanation of what a thing means. Wait, I cannot log in. I can log in. Continue. And I should be logged in. I am not logged in. My bad. And I am logged in. It is cool. I am logged in. This thing for this question, the explanation is this, which is, let's choose everything, which is this. I don't get the answer. Can you explain it to me? Try again sooner. Shit. Let's ask Elon Musk for an explanation. Let's break down the problem clearly, step by step. Problem overview. Start with an array A containing just one element. Problem overview is one. Compute the sum of the selected items. Add the sum as a new element to the array. It's anywhere. Anywhere I can add the sum. Anywhere, possibly zero number of operations. Key insight. The explanation provided is based on a mathematical property of the array as it evolves through these operations. The goal is to check if the target array C could have been formed by repeatedly applying the operation described. The explanation uses induction and a specific condition to verify this. Okay, induction, explanation of the solution. The solution hinges on the idea that this can be obtained from the initial array A. It must satisfy us property. Okay, when I'm starting at the starting, let's use induction. So our base case is this. When I'm starting, I know the lowest element I can create is 1 and the highest is also 1. So in this case, I create 1 and 1. And now my sum is 2 and the lowest element I can create is 1. So I can create any number between 1 and 2 and also 1 and 2 included. So let's create 2, 1, 1, 2. Now my upper limit is 4. I can create any number till 4, and to create the maximum I just take the whole array as the subsequence. To create 1 I just take this, and And to create any number, any intermediate number, I take some number from here. One, one, four, four, two, 5, 7, and 19. And when I sort this, I get 1, 1, 2, 5, 7, and 4 was also here, and 19. For 1, I check and I see it is possible. So correct. We move on. For 2, the sum here is 2, so it is also correct. We cool. Sum here was 1, sum here is 2, so we are cool. And sum for 4 was 4, so it is also cool and doable. And then the sum became 8, so 5 is possible, that is cool. And for 7, the sum uh, the sum became 13, so 7 is also possible. And for 19, the sum became 20, so 19 should be possible. But if this is the thing that is given to me, then 19 would not be possible. Yes. First one is no due to some reason. For the third case, which is yes. For the second case, performing any operation will change A to an array, at least to which you can only have two elements, but thus obtaining the array is impossible. So the answer is no. Wait, fuck. What is the a subsequence of B is a sequence a subsequence B a sequence B is a subsequence of A if B can be obtained from A by deletion of several, possibly 0, but not all elements. In other words, check if if K is between this and this distinct pairs, K insert anywhere into a new element with the value equal to this. From the start, select K distinct indices. Shit, fuck. They do not have to be in an order. Shit, fuck. It makes sense. Yeah, shit. The problem came because I didn't read this part. Shit, my bad. Fuck. My bad. Fuck, shit. How much time did I give this thing? 1 hour 28 minutes. Like more than half of the stream spent on one question. That is cool. Boilerplate 21 and int n cn n, and then what do I get? I get the array vi a size n, repeat l I 0 n cn a I, and then sort all a. And after sorting, after sorting a, I do yes, if ai, if a0 not equal to 1, then see out है see out no. Okay, shit, I changed my key mapping in Vim. See out no and break out of the if while loop, and then write just output no, and else I can add it in a else loop. Else I don't have to add it in a else loop. I 0 and if, and I need a running sum int s equals 1, and change this to 1 starting from 1. We will go if s is lower than ai, then we are messed up. See out yes max slash n and say done equal true. And what is done equals false. Now at the end, if not done, then see out yes yes, and let's see. Wrong answer is cool. Yes. Yes. Still okay. It is not running for all. Okay, I did break out of the loop. Chip that is bad. Continue instead of break. Still wrong answer. Why? Continue should have worked. Wait, still here it is no. Wrong answer still. And why am I getting more responses than I should be getting? All this here. Wrong answer. Oh, yes, break after this. Yes. And wrong answer for yes and yes. I said no and no. This thing should have been yes. One is possible, one is possible, one is possible, two is possible, four is possible. Why did I say no? I am only saying no here. Okay, because I am not incrementing the sum. Cool, yeah. Now it is correct. Yeah, sure, yeah. Now I'm thinking about the theory. Well, this is always correct. I have a sum, right? I can create some number x I can always create x plus 1 if I have x, and I can always create x plus 2 if I have x, because I always have two ones, and there would be a sum. Submit. This was pretty bad. It took me a lot of time to do this one. And I didn't do this. I just read the solution. Mm. I lost the question. Shit, hard version. Accepted. It says that is cool. I don't simply want to move on. Save to list. Create a list. Review. Add this to review. Save. Where can I see the list? I guess here. Shit, yes. There was an option here called list. Listen. So save problems. Review. That is cool. This next question. Subsequence addition. So the main problem in this one was that I didn't read the question correctly, and yeah, I don't think I would have been able to do this on my own. It would have taken me a lot of time. Refresh. This will become green. It is green now. Very small question. Li Hua has a pattern of size n square n by n. Each cell is either blue or red. He can perform exactly k operations. In each operation, he chooses a cell and changes its color from red to blue or from blue to red. Each cell can be chosen as many times as he wants. Is it possible to make the pattern that matches its rotation by 180 degrees? Suppose you are Li Hua. Please solve this problem. Yes, why would it not be possible? It is not possible in this case by 180 degree. I can change all the colors. Wait, what? Exactly K operations. Okay. K is also given. Okay. N. I have a square. N could be even or odd. And okay, I go from top. I match the top row with the last row and I see the number of bits that differ. Okay. And yes, like that. Okay. Something like this. If I have some stuff like this, 5, let's say it is 5 by 5, 5, and this is the whole thing. And for it to be same, this thing starting from here has to match this thing starting from here, this row starting from here. Like these elements have to be equal to these elements, and then these starting from here have to be equal to these, and then this middle row, if it is even, then this thing has to be a palindrome. Like, I need to first of all find out the number of cells that need to be switched, and if that is greater than k, then we cannot make this happen. and if it is lower than k, then I will find out exactly how many extra operations I have, and if that number is even, then we are cool, but if that is odd, then we won't be able to do it. Okay, this is cool. Starting with this. Okay. And would there be a different way for solving even and odd questions? And yes, that is David Goggins at the in the background, right here. David Goggins. We'll play 21 and n k n k and then a vector of vector integers called a of yes, I can give size, right? Vi size n. This is bool. Yes, this is bool. And repeat li 0 n, repeat l j 0 n cn ai j. Okay, I think that is cool. Starting from 0. This is cool. This is correct. After this, now I need to match. Okay. Repeat li starting from 0 till n minus 1, n divided by 2. If n is even, then it is cool. If n is odd, then I will, after the fact, I will check the last one if it is a palindrome or not. And let's end diff initially 0. And then I need to find the number of changes. Okay, int j is j, int j is n minus 1 minus I. Yes, n minus 1 minus I. I have to compare the ith row and the jth row. Ith row starting from the first element and jth row starting from the last element. Now, so x starting x from 0 till n, right? If a I bracket x not equal to a j bracket n minus 1 minus x, then diff plus plus. Okay, this is cool. This is cool. I can do that. Yes. And now if n divided by 2, if not n remainder 2. Now I need to check if it is odd. If n remainder 2, that is, if n is odd, then I need to find the middle number, which would be n by 1th, n by 2th row, and I equals n by 2. If n is 5, this would be 2. So 0th index, 2 second array and second diff, and I 0 n, except not I but j. Now if a j bracket I not equal to a j bracket n minus 1 minus I, then diff plus plus. Now after that, that is done. That finds me with if diff greater than k, then we are fucked. See out no in bigger letters, and else if else just else if k minus diff, either it is 0 or some positive number. I need to know that it is even. Else if not, else if k minus diff divided by 2, that is if it is even, then 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 it is wrong. If it is even, then see out no backslash n, else see out yes. Shit, I have changed my remap, so that's why I'm mistaking again and again. See, wrong answer. Cool. Uh, it said no for this one. Why did it say no for this one? Let's compare this. Okay, it is even this with this. So 0, diff is 0. Diff is 0 for this row. But for this row, I have to change this and this. I have to change these two. So diff should be 2 and I have to change both. In first case, you cannot perform any of it. The second case, you can perform this. The pattern after operations in the middle becomes this. Okay. To make them go away. If there is a difference, then I add that difference only once. Shit, this the diff should have been 1 in this case, and 2 minus 1 divided by 0 divided by 2 should be 0, and I should have outputted yes. So why? See out diff with a new line. Let's see diff first was 1, then it was 1, then it was 3. K minus diff is k is 3, diff is 1, so 2 divided by remainder, not divided by. Now it should be correct, except for the fact that I'm printing diff here. Now it is correct, and let's see submit. And it should be correct. Yep. Expected yes, found no. There's the question. Okay, 1. Okay, fuck. if diff is 0, shit, yes, if diff is 0, then okay, this is an edge case. Where do I put this edge case? If diff is 0, then it would be in this case, and here before this, before checking this, if diff n is 1, then no matter what diff is, we are cool. Yeah, I can do this right here. If n equal 1, then see out yes, and continue. See, submit, and shit, my name is now green. That is cool. Boom. Broke on test 4. Test 4. Wrong verdict on number 1. If this is what I have, and I can do this many operations. I have a certain amount of diff. That is cool. N is 9, so 2, 3, 4, 5. This is the middle row, and I do not have to change anything here. I can change this n number of times, this element, because it would always be at the same place. Okay, so that is the case. And k has to be smaller than, diff has to be smaller than k, which is here in this case diff is smaller than k, and I do not have to check this other condition. If n is odd, that is n remainder, if n remainder 2 is true, and k is larger than this, see out yes, and continue. Right, yes, looks good. Submit and drink water. It's been 1 hour 54 minutes, and I have done one question on my own and one question with help. Constructive algorithms. Greedy. Okay, what is constructive algorithms? And A greedy algorithm, I know a bit about greedy algorithms. And now the editorial for this thing. Problem B. We calculated the minimum needed comparisons came in easily by enumerating through the cells and performing an operation if the color of the cell is different from the target cell. Obviously, uh, if this, then no solution. Otherwise, there are two cases: n is even or n is odd. If n is even, then the solution exists. If this is even, yes, and if n is odd, then the solution always exists, and that is what I'm checking for. If diff is smaller, then if n is odd, if n is odd, then solution always exists, yes. Otherwise, solution only exists if k minus diff is even, otherwise not. So this is the most optimal solution. Shit, why isn't the background changing? Wallpaper, rotate the wallpaper, put to this and then rotate. Now I can move on to the next question. Teleporters, easy version. Okay, I should be able to do easy version. G1, I guess this is division 4. The only difference between easy and hard version are the locations you can teleport to. Consider points 0 to n on the number line. There is a teleporter located on each of the points 1 to n. Okay, starting at 1 till n. At point I, you can do the following: move 1 unit left or 1 unit right, both cost 1 coin. Use a teleporter at I. If it exists, it costs AI points. Use a teleporter at I. If it exists, it costs AI points. There is a teleporter located on each, and if it exists, use AI. As a result, you teleport 2.0. Once you use a teleporter, you can't use it again. Okay, I can only use a teleporter once, and the cost of using AI, and as a result, I will always be teleported to point 0. Okay, you have C coins and you start at point 0. What is the most number of teleporters you can use? Okay, if I used once, one, then I cannot use one more. And AI costs, AI, okay. First is N and C, total number N, and C is the initial thing that I have. Okay, initial, okay, okay, and wait. Let me hide tags and exception rating. I am still able to see the tags. Now it is hidden. Cool. And given n and this. So if I have n and this is my cost at every teleport, to use a teleporter, I first of all have to go to that point and then I will come back to where I was. Okay. So I guess the total cost of using one teleporter would be cost C plus its index, whatever it is, right? Index plus C, and as a result, I will use up all the teleporters. Hmm, which add cost. Hmm, I think I got this. Odek boilerplate. Int NC in NCL. Not VI. I don't even need vi. I do need via, size n, I 0, n, and then a cn a I. Oh, shit, I changed my remaps and okay. Uh, okay, this cnai and then sort all a and then and s equals 0 and s equals 0 and then while s smaller than c and c equals c. I already have c, so answer equals 0. So after this answer plus plus, I used one more teleporter and s plus equal AI, and I will also need AI. I don't need AI. I can make this thing I starts at 0, uh, uh, and this thing I plus plus and SAI. Add this, go to the next. Add this, go to the next, and also and I lower than N. And named C out I. The heel is that C out I with a new line. C, and that is the wrong answer. Shit. 541 6. Where am I initially? 5. The length of the array and the number of points you have. 1 to n. Okay. 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 My bad. This thing. This has to change. Control O P and shit. I'm getting slower because I have changed my remaps and I'm trying to get used to the new ones. Earlier my caps lock used to work as escape, but now I have remapped it to be the control key, and it will take some time to get used to it. And yes, with my pinky I have to shift between the shift key and the caps lock key, which is very troublesome. Cost is I plus 1. Still wrong. I expected to work this time. It is working for some of them. Okay, it is always one higher than. Okay, if some. Okay, I add only if s plus s plus AI lower Okay, I guess a while loop would not be good. Tell I 0. No, no, no. For I less than n I plus plus, and if s plus ai is lower than c, then s plus equals ai, then s plus equals ai. I can increase ai. Let's see, it is still seems to be fucking wrong. I've sorted a I plus 1. Mm, this wouldn't, that wouldn't mean anything. I I sorted A, and only then I'm doing this. S is initially 0. I is less than n, and okay, if this then fucking break it, my bad. Else break. Shit. Okay, I gave 0 and 0 for these two. For the fourth one, 1, 2, 3, 4. I said zzz, even if it is equal. And if at one point it becomes greater than that. Cool. Submit. Let's see, and I guess it will work. First try. It should work. Yeah, it does. We can move on to the next one, negatives and positives. I've done 3 questions today till now, which is fine, but not great. I will do a couple of more questions, maybe 2, maybe only 1. Given an array A consisting of n elements, find the maximum possible sum the array can have after performing the following operations any number of times. Maximum sum it can have. Okay, choose two adjacent elements and flip both of their signs. In other words, okay, numbers can be negative, positive, anything. Okay, in other words, choose an index I such that I is always less than n minus 1 or even equal to n minus 1, and then make ai equals to minus I and ai plus 1, the next one. Also the opposite. Okay. So for every pair, I can take the initial sum of the array while I am taking in the input, and for any pair I would only like to flip the bits, flip the sign if flip the signs. Okay, if both the numbers are negative, if both the numbers are negative, then of course just flip them. Do not think about it. If one of them is positive and the other is negative, then I would only flip if the if the absolute value of the positive number is smaller than the absolute value of the negative number, and if both are positive, then I would have no business flipping them. And how do I find? So do I iterate through all the pairs, all consecutive pairs? That is, I go from here. I see. Cool. We flip this. So the next pair that I go to, should it be this or something else? Even if it is this, then it should be cool. Sign does matter. Here I would not flip anything. Here I could or could not. I guess I won't. I won't. And here I should flip because the absolute value of this is greater than the absolute value of this, and here I should not flip. So I can make this also positive, then the sum would be 13 and the answer is 13. Here I will not flip. Here don't flip this pair uh, don't flip anything. And the sum would be 10 plus 9, 19. 19 plus 7, 27, 27 plus 27 plus 12, 39, 39, 39 is the answer. Here I should flip and the answer would be 2. So the only concern that I'm having is, does ordering matter? I will not flip this, but if it were -5 here and +5 here, hmm, then it would be ambiguous. So I cannot use a greedy algorithm. What it means, flipping the sign. I can go, and my goal is to flip the negative numbers and flip the negative numbers and make them positive. So when I make this thing positive, then one of these is going to change their sign, and nah, I can go on and look for negative numbers and see if they have a negative neighbor, then flip. No, it would not work. In the case when I had -5 here and +5 here, then I would flip. This -5 would become a 5 and this would become -5 as it is given, and then I would flip again this pair. So I need some strategy. If there is a fucking 0, if there is a 0, I guess, then I can afford to do any number of flips there. The neighbors of a 0 will be always positive. That is one thing. And if two negative numbers are neighbors, then I flip them. There has to be a strategy. I cannot use a greedy algorithm in the case when I get 1 minus 5 plus 5 and then 0 and then 2. Shit. Questions are getting harder. 1 minus 1 minus 5, 5, 0 and 2. Then my solution is to flip these two, and then this would become plus 5, this would become minus 5, 0, 2, 1, and then flip these two and I would get 1, 5, 5, 0, 2. Hmm. So my goal is to flip the negative numbers and make them positive. And I will go to every negative number and see can I make this positive. Or propagating a sign. If I have, let's say, propagating a sign, I have 1 minus 5 and plus 10, 500 and then 0 and then 2. Can I take this minus from here to there? If I choose this pair, then this becomes positive and this becomes negative. Okay. This becomes positive and this becomes negative. Then I choose this pair and this becomes positive, this becomes negative. I choose this pair, this becomes positive, now 100 is negative and then this becomes negative. Okay, cool. If I have a 0, then I can always propagate the sign to 0. Shit. Yeah, I can all, but if there were already negative numbers here, then I first propagate that first appearing negative number and okay. 39, this one, fucking cool. Okay, now I have a solution. No. PLV boilerplate 21. Int n, right, and then the numbers. Cin n vi. I don't need vi actually. I can just int c and sum 0. Okay, and I do have a plan with this thing. I 0 n, take the number n to c, and also one more thing. Mn initially is max or int max, but I'm using 64 number. Still, this is fine. mn equals minimum of absolute, or more like, shit, is my camera working? Thought it stopped. Wait, let me fix my camera. Just a minute. Let me fix my camera. Um, so iPhone camera. Yeah. I'm trying to fix my camera right now, and you guys cannot see anything. Not even my face. Shit, it should have been fixed, but it is not working right now. Wait. Stuff like this should not happen. This is bad. Okay, anyways, I'll just continue. I'll simply continue solving the question even without my camera. Right, you guys can see the screen. Camera is not working. That does not matter. It is fine. Okay, after taking in Cn, C equals absolute value of C, and Mn equals minimum of C, minimum of my bad, minimum of C or Mn, and then S plus equals C, and then C out. Answer would be S minus Mn. Yes, just that, because I can propagate the negative sign. Or okay, yes, fuck, yes. How many negative numbers do I have? Okay, it would depend on that also. How many negative numbers do I have? N, ng negative initially is 0, and if c lower than 0, then ng plus plus. After that, at the end, if ng remainder 2, that is, if ng remainder 2, which means there are odd number of negative numbers, then I multiply the negative number by 2 and see out s minus 2 into mn backslash n, else bruh, 5 2 5 2 third 1 2 3. Shit. Okay, if else, then I do not minus at all. I can make all of them positive. Yeah, correct. Cool. Select all, submit. I think I am mistaken a bit. The way that I am solving these questions, I am solving this question, but I do not know what algorithm I used or something like that. Right. It will be submitted, it will be accepted. Yeah, it is accepted. So after solving problems, I have to change my way of solving these problems. Let's say I do this and then I see I have to do dynamic programming this greedy algorithm and sorting. Have I done any of those? No, I have done nothing like that. I just simply did my iteration. Shit, it was not that hard that I had to use greedy algorithm, sorting, or dynamic programming. Fuck, those are two big words, very big words. And two as in like T-O-O-2. GCD participation. E, this one was E, and division 4 competition. Tutorial negative positive numbers. We notice that by performing any number of operations, the parity of the count of negative numbers won't ever change. Makes sense, as if the parity won't change, as if the number of negative numbers is initially even, we can make it equal to 0 by performing some operations. So for an even count of negative numbers, the answer is the sum of the absolute values of all the numbers, since we can make all of them positive. And if the count of negative numbers is odd, we must have one negative number at the end. We will choose the one smallest by absolute value and keep the rest positive. For simplicity, we consider -0 as negative number. Makes sense. That is what I did. So nothing like dynamic programming, greedy, or sorting was used in this. Huh. So this is wrong. And now I can move on and do the next one. Has been, how long has it been? It has been 2 hours, 27 minutes. I can do a couple more questions, at least one more. While at Kira's house, shit, Kira. While at Kira's house, Josuke saw a piece of paper on the table with a task written on it. Task or someone's name. The task sounded as follows. There is an array A of length n. On this array, do the following. There is an array A of length n. Okay. Do the following. Select an integer k which is greater than 1. Split the array into k subsegments. Okay, I will read the definition of subsegments in a while. Calculate the sum in each of k subsegments and write these sum to another array B, where the sum of the subsegment L R is summation J. Okay. In B, AJ. What the fuck? Wait. B. Okay, where the sum of the subsegment LR is this thing. The final score of such a split will be GCD this. Greatest common divisor of this to this. What the fuck? Okay, divide the given array into k subsegments. Okay, a division of an array into k subsegments is k pairs of numbers. K pairs of numbers. L1, L2, L till Lk, such that L is to the left of right or equal to right, and for every this, both L and J, for every J between 1 and K minus 1, L J plus 1 equal to R J plus 1. Yeah, it's clicked. Minus 1 L J plus 1. What is, okay, L J plus 1, the J plus 1th pair plus okay, the left pair of any number has to be 1 plus uh, one to the right of the last pair, okay, except the first one, it has to be 1, and last one has to be n. These pairs represent the subsegments. Okay, okay, this much I get. And calculate the sum in each k subsegments and write these sums to another array b. And b, I guess, will have length k. Okay, okay, where the sum of subsegment LR is this thing makes sense. The final score of such a split will be greatest common divisor of this. GCD of this stands for the greatest common divisor of the array B. Okay, what do I have to do? First, I'm getting n, which is at least 2 and pretty big, till 500,000, 10,100,000. This is a million. My bad, which is equal to 200,000. The length of array A, the second line contains n integers, a to n, the array A itself. Okay, this this one is crazy. This one is crazy. I have to. Where is K? Where is K? What? Where is K? Do I have to iterate for every K? Mhm. Select an integer K. Shit, I have to select an integer K. Shit. Here, if I do select K equal to 2, then this sum would be 4, and this sum would be 4, and the GCD would be 4, and answer would be 4, which it is. And it would be for k equal to 2. And here, if k equals to 1, then the answer would be 1. Okay, and k only represents the subsegments. Fuck. Okay. A division of an array into k subsegments is k pair of integers. Okay, okay. I can divide them into any way I want. Okay. Add these. I guess, shit. If I were to, if I were to select, first of all, I have to land for k, and I have to find the most optimal k. And second of all, for every k, what would be the division? What would be the way to divide these numbers in a way that would result in the maximum GCD of their sums? So two things, and for the part in which I have to find the best k would be easy. I can just run binary sum. The smallest value of k would be 1, and the maximum value k can have is n. So finding the best k is easier, but for every k to find the best split possible is hard. Let's say k is 2 in this, let's say k is fucking 3 in this case, and if k is uh, uh, no, 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 no. No. If one has a factor of something, if 3 is a factor of 3, but if I add 1 to it, 3 is no longer a factor of 4. So that is crazy. If I have 3 here, then what can I do? Yes, 2 hours 34 minutes. Here, I could choose k equal to 2, and then this would be one subsegment, this would be one subsegment. But how do I land on that? Here the answer is 1, which is unexpected. Okay, does parity has to do with something? Here elements are of different parity. Mm, nah. 2 3 0 3 7 8 8 1 2. What can I do? What can I do? What can I do? If I choose k equal to 1, then this whole thing is my sub. Wait, what? K, I think k cannot be equal to 1. Choose an integer, yeah. K greater than 1, yeah. If k were 1, then I would simply choose the whole subarray, and the sum, whatever the sum is, that would be my greatest GCD possible. So k has to be at least 2. So here also I choose k equal to 2. The question is, in the first case you choose k equal to 3, in the fourth case you choose k equal to 3 and split the subarray into these, and the score is this. In the fourth case I choose it equal to 3. One is this subsegment. No, one is this subsegment, this one, and another is this, and the next is this subsegment, and order also matters, which is crazy. So starting from the first element, I move to the right. Starting from the last, I go to the left. Mhm. Uh, nah, doesn't work. It doesn't work. I think parity, something that I have to do with parity. Cannot be sure. Divide this into k. The thing that I have to find is a method which I can use to find the best subarray with the best GCD. Something from the question. It is just B. Fuck. Is this division 1? It is division 2 and B. That is crazy. 2 years ago. And it is supposed to be 1,000 level question. Shit. Uh, we have LGM. 7 tasks in 2 minutes. Teams standing. What can I do? K. For every K, I have to find the correct thing. Should this guy has done 10,000 problems. Mass P. And he is an LGM. That is cool. Don't get distracted. Get back here. 12, 30, 37, 88, 12, 78. I need to away. make it white. We are racist. So, uh, shit, that is too big. Okay, we have this. Uh, Make it a little bit bigger, like that. Then let's say my k is 1. K cannot be 1, my bad. Let's say k is 2. Then I need to make 2 pairs. So my L is 1, for the first L is 1, and the last right is n minus 1, which is this points here, and this one points here. Then the number of variable I have that I can twist, move left and right is only 1. Let's say this is the boundary separating the left part from the right part, and I can take this, put this anywhere I want. So that would be cool. I do not want to do this in brute force. This would be an optimal way. It would be easy in brute force if k were 2, but k will not always be 2. It will also be equal to 3. Let's make this as big as the above one. And let's say k is equal to 3. Now, as my first list starts from here and the last one ends here. But now I have 2 variables that I can change. Let's say this green one and this blue one. I can put this green one in here, here, anywhere, anywhere. It just has to be to the left of the blue one. And whatever is the blue one, I can also put it anywhere. It just has to be to the right of the green one, and whichever combination I land with, the array to the right of the blue one would be my third subsegment, and the one in the middle would be my middle subsegment. The middle in green and blue, between green and blue, would be my second subsection, and to the left of the green would be my left subsection. And I can choose them in any way, right? Yeah, I can division of k into this is this. It can be arbitrary. Yep, in this case it is arbitrary. Case 2, we split into this and this. Uh, it is not arbitrary in this case. In the fourth case, k is 3, and here it is arbitrary. We are only choosing 2 elements in the start, and in the middle we are choosing 3, 4, 5, 3 elements, and at the end we are going with simply 1 element. So if k is 3, and then it means I have to choose 3 numbers x, y, z that add up to make n, right? My first subdivision would be of length s, then the second would be of length y, and then the third would be of z, and the total number of possibilities would be quite a bit. How many 3 number pairs are there which add up to n? For x, I could take any number beginning from 1 to n minus 2. So I have n minus 2 possibilities for x, and for y I have n minus 3 possibilities. No, n minus 2 possibilities in the other two, and for z I have n minus 2 possibilities. Shit. So if I were to do this in brute force, the time complexity would be around n power k, and I will have to iterate k from 1 going up till n. So this plus shit, the total time complexity would be n power 1 plus, no, I cannot have k equal to 1, n power 2 plus n power 3 plus dot 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 till n power n mission, and that would be just n power n, which is fucked up. We should not have this great of a time complexity, and my camera is still off. So I guess I will end the stream here because I do not see any way to solve this for like right now. Maybe I will think about this solution, think about this question tonight, and tomorrow I will probably read the tutorial for this. Tutorial GCD partition. It is just this much. Tomorrow I'll get into this. And for now, tourist is at the top. And I'd like to do a little bit of Wordle, and then I will end the stream. Let's see. This, what the heck is this thing? In Africa, something? I don't know. It is definitely not Burkina Faso, but it is in Africa. Cameroon, maybe. Okay, below Cameroon. Namibia. Namibia is on the coast. Okay, above Namibia. Gabon. Okay, pretty close to Gabon. To the right of Gabon. Congo. Democratic Republic of Congo. Ah, yeah. Cool. Shit, it has a lot of neighbors. Uh, uh, Not Gambia. It has Central African Republic, Republic of the Congo, Namibia, I guess even. No, it doesn't have Namibia. Okay. Angola, maybe? Angola, okay. And Zambia, Zambia, okay. And what is above Cam Cameroon? I think this is wrong. Yeah, this is wrong. What are the other things? Gabon is also not there. Shit. Tanzania is also not. Tanzania is there. Shit, my bad. Tanzania. What is above? Sudan, maybe? South Sudan. South Sudan. Okay, cool. And what is this? What the heck is this country? What is this? This looks familiar. This looks like a heart, but bruh. Hmm, what is this? This is a coastal country, and it has coast on the south. Okay, fuck. Okay, maybe Rwanda. Rwanda. Yeah, fuck yes. Rwanda, and what is Uganda? Okay, and one more place below Rwanda. What is below Rwanda? Shit. Malawi. Shit, Malawi is not there. What is below Rwanda? Fuck. Uh, Above there is, in the north there is Uganda, then in the south of Uganda there is Rwanda, and the south of Rwanda, which country is there? Fuck, its capital, I remember its capital is Uh, Gita Gay. Gita Gay. Yeah, Gita Gay. No, 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 its capital is not that. Oh, shit. I don't remember that country. Fuck. Burundi. My bad. Burundi. Burundi. Yes. Fuck. Burundi. Okay, cool. Where did it go? Close the map. Wordle. And cameras is still fucking not working. But at least my screen is there, visible, with this thing. This is from Chainsaw Man, which is cool. Chainsaw Man is cool. Capital city is Kinshasa. Where is Kinshasa? Maybe here? On the border somewhere. Ah, fuck. First try. Okay. Uh, the flag is. I know the flag. Flag is. Shit, I forgot the flag. This is Angola. This is Central African Republic. Hmm. I think it is this. It could be this or this. One of these. Yeah, this one. Democratic Republic of Congo, and that is Tanzania. Okay. South Sudan, Republic of Congo, Burundi, okay, Rwanda, and all that. Okay. It is not on the coast, so not this, but it has a sea there. There is a sea. This ancient civilization. These houses look too beautiful to be in Africa. Maybe this. Fuck yeah. Okay, what is this place called? It is a sea. Uh, Lake Kivu. Okay, this is not the thing. Art could it be? Uh, it is not this because this tree does not look. Yeah, this is this one is from Central African Republic. This is Taiwan. This is Taiwan. This is Taiwan or Laos. This is Taiwan. This is Azerbaijan. This one. This one on the right. This I don't know. This is also not it. This is Brunei Darussalam. This is yeah, fuck it is this Azerbaijan, Taiwan. This Lesotho, Mauritania, and that one is Central African Republic. Cool. Next, easy mode. Fuck. Language I don't know. English. Uh, Afrikaans, French. I don't know the language. For Swahili, I've heard Swahili. I've heard the term Swahili, but I don't know anything else. This is Greek, and I guess they would be kind of similar, like these two, or exactly wrong. Population. It is a big country. More than 100 million would be too much. 80 to 100. Ah, shit. There is too much. Okay. Uh, Kina. Fuck, why is franc used in Africa? Kinshasa, Lubumbashi. Uh, I've heard Goma, so I'll put Goma above. And it is wrong. Okay, Goma is at the bottom. My bad. Export, I don't know about exports. Maybe diamond, stones, precious stones. Shit. Isn't the There are diamond refinery in uh, DRC, which is very big and famous. Okay, annual products, nope. Of course not computer chips and stuff like that. So what else? What options do I have? Chemicals? Right. Not even chemicals. Stones, electron, clocks, something like that. No, copper. Okay, base materials. Copper, top export. Okay, let's make it bigger. Copper is pretty big, and on the second, other base materials, I'll put that on the second spot and make copper a little bit bigger. Then maybe precious stones would be on the second. This seems right. Oh yeah, kind of right. Yeah. Area. It is to be around hint. It is bigger than Spain. I would suppose that it is bigger than Spain. But how much bigger? Spain is 500. I guess this. Fuck, it is very big. It is very big. Shit, it is like Algeria. Shit. And let's first of all just see the size. Here we have, shit, it is pretty big. DRC. Never noticed that. So that is taking quite a chunk. And Spain is tiny compared to this. Here we have DC, DRC. Angola is also pretty big. Okay. Hmm. That would be the end of today's stream, even though my camera is not working. Yep, this would be my exit screen like this, but camera is not working. So yeah. Anyways, 2 hours 57 minutes, 21st of July, and that's it. Bye. Thank you for being here.